It might be live. I think we're live. Can't tell. Am I live? Am I live? There's no viewers. Oh, I might have screwed it up, people. Well, welcome. This is RockSim Live, and now that screen died. What happened there? Oh, we have Terry Wheelock in the house. Say something, Terry. Oh man, there's a lot of technology involved here, and I clicked the wrong button and ended the stream prematurely. And then once you end it, you can't get it back. So you got to start a new one, and I didn't know how to start a new one. But I'm live. Oh, cool. People are checking in. Awesome. I got, it seems to be working. This is RockSim Live, and I'm your crazy host, Tim Van Milligan. Yeah, we got chats going on. Cool. What is the Goonie Go-Go? It says Terry. We have newtons per second from Massachusetts. We probably dropped a lot of people because when I ended the stream that dropped off, but they're trickling back in now, so thank you for coming. This is RockSim Live. Let me get my desktop here so you can see what I'm seeing. Oh boy, so I got Windows running here. This is the Apogee website. Why is my mouse not working? Here is our RockSim training. This is what we're doing right now, RockSim training. So we are here to answer your questions about RockSim. I don't have any questions that came in over the past week. So I am counting on you to give me some questions to answer. We got Carlos. Carlos says, finally got in after getting whacked once. Yeah, that was me. I accidentally whacked people by clicking the wrong button. There's like too many buttons, and I tried to do something fancy by adding a countdown clock at the beginning. And yeah, that didn't work. Well, I got the countdown clock, but then I accidentally hit the wrong button. I'm not sure I like that countdown clock, but it did start counting down. Today is March 31st, 2023. We have a special offer going on for March. You get a free scale when you order $150, but you have to add it to your shopping cart. It's a nice little scale. I use mine every day, like several times a day, weighing stuff. You know, when you're putting things into RockSim or weighing up epoxy or doing ejection charges, it's way useful. But that ends tonight at midnight, because at midnight we're starting a new tool of the month. So if you want to get this one free, you got, I don't know how many hours, you know, like 10 hours left to go. Just a little under 10 hours left to go. And then that will be done. You can still buy the scale, but now you have to pay full price, and it's like $15.95. But this is a RockSim Live training. This is where, you know, we have our archives, so you can see what topics we talked about. And if you're interested in something particular, you can do a Command F, and it brings up a little finder window, and you can do like pods, and it will tell us that we talked about the word pods 8 times. So that's how I find things when I'm looking for things. You know, when customers email into us, you know, and I'm looking for a topic, you know, to give them, you know, answer their question real quick. That's what I do. I come to this page and I just do a find on the page. If you're new to RockSim and you've never used it before, you hit on How To and Guides, come down here to Software, and you can download the free trial. There's been a school that's been downloaded. They've had every kid in their class download it. And it drives me crazy because it's like they could download it once and put it on a flash drive and then just stick it in all the computers. But that would be like too smart. Because when the kids try to download it, they type in their email address wrong, and then they have to do it 20 different times. And I know they're frustrated. So if you're with a school, just put it on a flash drive and just plug it into each computer. That's the fastest way to get it downloaded. You can purchase it. You can find out what it is, but we're going to be talking about that today. We have training tutorials. We have the RockSim Live training, which we're talking about. Version history and system requirements are listed here as well. It does run under Windows 11. And I'm finding out there's different versions of Windows 11. So I don't know if it runs under your Windows 11, but I am running Windows 11 right here, right now, and it runs just fine. Okay, Carlos has the first question. Carlos is from Marietta, Georgia. When launching important rockets, do you recommend first launching sacrifice rockets that RockSim says will have similar Apogee checked upper winds? So, when launching rockets, do you recommend first launching sacrifice rockets that RockSim says will have a similar? No, I just say go for it. You know, if you want to launch a sacrifice rocket to the wind gods, make it a small one. Find out where your winds are going, but then just launch, your normal rocket that you've tested out in RockSim, and that's what I do. I don't do anything like that. Any other tricks that you can share? Oh, I got a lot of tricks, but I can't think of any off the top of my head. You got to kind of pry them out of me. Terry Wheelock says, show us how to design a finless rocket. Well, that's easy. But it's not going to be what you expect. Where's my RockSim? I have RockSim Pro running. RockSim Pro is, the design interface is just like RockSim, so we'll use RockSim Pro. Okay, so a finless rocket, think of a cone. So we're going to design a cone rocket here. So we're going to start with a body tube or a nose cone. And whenever you start, it always looks in the database. I'm just going to cancel out of that. And we'll just create this on the fly. So the material, we'll select paper. So I'm just going to scroll down to paper. And it's going to be hollow. We'll give it a wall thickness, I don't know, 0.01 inches. A diameter, we'll make it like a 6.5 inch diameter. The length, okay, so now we're drawing our cone rocket right here. So there's our cone. And we'll click, where's my OK button? There it is down here. All right, so we have our nose cone. Now we have to put in a body tube. So we're going to click inside tube. And this time I'm going to select from the database. I'll select an 18 millimeter by 2.75 inch long tube. And on this screen, you can't see it. Let me make it a little bit bigger. Okay, so there's our body tube, but let's move it back to here. Well, let's recess it a little bit. One of the things with rockets is we got to make sure that that center of gravity is in front of the center pressure. And right now we're behind, so it says unstable. We'll call this the engine mount tube. And we'll click OK. Oops, I forgot to do one thing. On that screen, there's a little box right over here that says this is a motor mount. You got to check that. And it's going to be 18 millimeters. Click OK. Actually, I want to do one more thing. I want to load an engine at the same time so that we can kind of get a gauge of how much nose weight we're going to need to add. Estes C6-3, engine overhang of 0.5 inches, so it's going to hang out the back just a little bit. So there's our rocket engine, the brown part. So our center of gravity is back here, so we need to add some nose weight to move that center of gravity forward. So I'm going to click on here on the nose cone, because that means I want to add some mass object to that nose cone. And again, it looks in the database. I'm going to cancel out of that. Let me make this screen bigger so you can see what I'm doing. And we'll add, I don't know, let's add 30 grams. And it's going to go like right there. So at this point, our rocket is stable because the center of gravity is in front of the center of pressure. So we'll click OK. Oh, come on, my mouse. And let's save this design. And I'm just going to throw it on the desktop if I can find my desktop. There it is. And we'll just call it Cone Rocket. Hit save. All right, so let's launch it. So we've already got the engine loaded. Flight events, nothing's going to happen. We don't have a parachute in it. Starting state, 60-inch launch rod. Let's make that 36. That's your standard size. Degrees from vertical, 13. So that's kind of arced over. This is kind of like your launch angle control. And here is our azimuth angle. So this is like a compass. So north is at the top, east is to the right, south, and west is over here. So we're kind of launching to the northwest. Our launch conditions, I'm not sure where this launch site is, but we'll find out pretty quick here. But it's 422 feet above sea level, and we have a temperature of 59 degrees. Under wind, we have a 4-mile-an-hour wind coming out of the west. So this is the compass direction. So west is 270 degrees. So 0 degrees is north, 90 would be east, 180 is wind coming from the south, and 270 is wind coming from the west. And we'll go ahead and launch this. And since we're in, ooh, this is doing 200 simulations. I didn't turn that off. Cancel that. Or we'd have to sit here for 200 times. But it still ran the simulation, and we'll have the rocket sitting here on our launch pad here as soon as it is done loading the maps. So we're in this field. It's a nice little field. There's no crops in the field right now. And yeah, so when we launch it, where's the rocket? I can see the rocket down here, but I'm not seeing it in the screen. Let me pause it here and let's get a different angle and zoom in. All right, so there's the rocket. The rocket took off. Oops, no, it's not tracking the rocket no more. There's our rocket, and it's arced over, and it's going to generally come screaming down into the ground. So it's going to point to the ground, nose first. Let's turn on some things to make it easier to see. So let's turn on the trajectory path. Let's make that green so we can see it. Ground track I want to see. I don't need to see the time intervals. And the extruded path, and let's turn on some smoke. Yeah, we got the smoke on. Okay, so let's zoom out just a little bit so we can see this thing. It's gone about 460 feet into the air, and it's coming screaming down. The wind is catching it. Now with the motor burned out, it's pretty light. So so there's our path. You can see that's at Apogee now, and it's coming down, and it seems to be coming down just as fast as it went up. And you can see by the trajectory that, and I'll pause it here when it gets to the point I want. It's picking up speed. You can see it seems like it's going faster, but then it starts arcing back into the ground. It is stable. And so it's got this curve, and it lands onto the ground. It's coming in nearly straight up and down, which is kind of cool. It didn't go very far. It landed 96 feet away from our starting point here in the middle of this field. So I know that's, you know, not what you expected of a finless rocket, but it's stable. Yeah, it's the fins provide a lot of stability. The other thing that provides stability is a spinning rocket. And since we're in RockSim Pro, we can do a spinning rocket. So let me start this design over again. So I'm going to create a new design, and it's going to ask me if I want to save the old one, and I'm going to just say, sure, I already saved it once. Okay, so then to start a design, we start by going along here. So under the Rocket Design Attributes, oh boy, what's going on here? There we go. You got to find the right spot. I've heard people having problems clicking on this button, and that is weird. Now I'm seeing it for myself. If you get like right on the second T, it seems to work. Yeah, that is weird. I'll have to inform the programmers of that. Okay, so this is going to be finless rocket. We're going to use the RockSim stability equations. This past week, somebody asked what was the difference between RockSim and Barrowman. RockSim is Barrowman, but the original Barrowman equations had a lot of assumptions in it, because at the time that they were generated, it was like 1965, so this was getting close to 60 years ago. They didn't have computers that could do all the calculations, so he made some simplifying assumptions. And what the RockSim method is we went back to the original report and took out all the simplifying assumptions, because now computers can do the math for us. So that's what the difference between RockSim and the Barrowman method is. So it's a single stage, and that's going to be fine. So this time I'm going to do a more traditional rocket, except for it won't have fins. So let's do I'm just looking for, okay, 24 millimeter nose cone. And let me change the color of this nose cone, because blue is just not my color today. Okay, so there's our nose cone. Click OK. Let's add a body tube. So that was a 24 millimeter nose cone. So we need a 24 millimeter tube. And there's a tube. And let's change the color of this one. Make it pink. And lighter blue. Okay. All right, let's add a motor mount tube. Let's see, do we like the length of this? It's pretty long. Let's see if that makes any difference. So let's add an inside tube for our motor mount. So it's going to be an 18 millimeter motor mount. Let's make the length 2.75. And change the location to the base of the owning part, and then just move it all the way back to there. So there's our motor mount. It is a motor mount. Let's load an engine like we did before. And I always choose like a C6 or a D something, because I always want the heaviest motor in there as possible. Let's choose a 6-second delay. Okay, so this rocket is very unstable. Let's add a parachute. Let's change the name of this tube, so engine mount tube. Okay, so I'm going to add a parachute into here, and it doesn't have to be a big one. So we'll just make it a 12-inch, and color. Let's make it yellow, and that color. And right now it's right here in the nose, and I'll move it back. So click on the General tab, and here's our location right here. So I'm just going to take this slider and just slide it back. So it's more stable, but it's still unstable. You can add your other mass objects in here. Let's add a mass object here and into the nose cone like we did before. So we're going to put a mass object in there, cancel out of the database. And before we used 30 grams, and that seemed to work, so let's use that again. And let's move it here. Okay, it's still unstable, but it's getting closer. Before it was -12. So -12 means that this center of gravity is 12 body tube diameters behind this. Now it's 7.65 body tube diameters. But we're never going to be stable by adding nose weight, because the only thing that we have that's providing stability is the nose cone, and its center of pressure is right here. According to the Barrowman equations, body tubes don't contribute to the center of pressure. So that's why we're never going to be able to move this center of pressure back unless we put fins on it. Or we could put a nose cone on a pod back here. That's another way we could do it. Now we got into, this is a good question, Terry. He thought he was being a smart aleck, but actually he got into some really good questions. He asks another question. Does RockSim compensate as the engine burns for the mass weight change? That's a good question, Terry, and I can show you. The answer is yes, but I'll show you. Okay, so we added this nose mass. I'll call it a nose mass. Click OK. So here's our nose mass up there. If we look at it in 3D, yeah, so there's our rocket so far. Let's save this rocket, and we'll call it Finless Rocket 1, because we might have more than one version. Okay, so let's just launch it to see what's going to happen. So let's see. So the flight. So we have a C18 is our motor. So that's a Quest motor. It's a high thrust motor, and I kind of chose high thrust because long burn motors and finless rockets. We're designing a bullet, and for a bullet to be stable, it's got to go fast. So that's why I chose the C18. So we do have a parachute, and we'll eject it at the maximum ejection delay, and our delay was, what the heck is going on? Interesting. Why can't I click into this engine selection? Okay. My programmer's got this. Sometimes, Windows, when they change Windows, it will break things in RockSim, and then we got to fix RockSim. I didn't want to have to do another fix before we release version 11. I'll be able to tell what's our engine delay here in just a second. So starting state still launching straight at 13 degrees. And let's just launch it again. So let's see what this thing's going to do. I forgot to turn off that. I'll do that the next time. Okay, so here's our rocket sitting on the pad. And I am pretty sure that this one's going to go unstable. So here's the rocket, and when we launch it, oh, look at that. It went mostly stable until that point when it flipped on its rear. Interesting. Let's turn on this stuff again. And I don't need to see the interval points. Why didn't that remember? Okay, so let me go to the end. You can't. Oh, look at this trajectory. So this is the landing point. Here's the launch point. And so, and if you look at the ground track, it started out. Remember, we launched this kind of to the northwest. So here's north is now vertically. We launched it right here, and it went this way, but then it started going that way. And that dot right there is our apogee point. And so it was still going up, and it changed trajectory while it was still going up. That was because probably around here is where probably the rear end of the rocket started going unstable. So let's see that again. Okay, see if we can launch it. So it's taken off, and right there, you know, the back end swinging around to the front, but it still went pretty high, 600 feet maybe. And now it's coming down. Okay. So that was pretty fun. Let's see what we can do to this to see if we can get it to perform a little bit better. So one of the things you can do in RockSim Pro, and this RockSim doesn't have this feature, but RockSim Pro does, is you can spin the rocket like a bullet. And that is on, oh, so here it is. It was a 6-second delay. So under starting state, I can give it a starting roll rate. So this is spinning it. And so right now we're in degrees per second. So if it was 360 degrees per second, it's 1 revolution per second. And that's not very fast. So 2 revolutions would be 720. 1440 would be 4 revolutions per second, or degrees per second. So four revolutions per second is what I'm going to do here. And let me turn off the uncertainties here. So it's 0 uncertainties. So when we do a flight profile this time and we launch it, look at that. By spinning it, I can already tell we went from 585 feet. We're going this time to 1178 feet on a C motor. And let's zoom out a little bit. So there's the rocket on the pad, sitting in the middle of the brown field, and it's going pretty straight. You can't tell it's spinning though. But that was not a bad flight, you know, and that's just by spinning it. So how do you spin a rocket that doesn't have fins? Well, you would probably have to put it on a turntable, you know, like an old record player, and, you know, spin it and launch it. You'd probably have to have your launch controller, like a wireless launch controller, sitting right under your launch pad, so you could sit it on your turntable. That might work. Never tried it. If somebody does, try it. Send me pictures, or better yet, a video to see if that would do it. So this should be remembering my stuff here. All right, so the trajectory looks a bit different. It was this time. It's kind of curving this way, and that is interesting. It kind of looks like a number 7. All right, so that was cool. So that's, I would say that's a successful finless rocket, but you got to spin it. What else could we do? And I was kind of alluding to this, is we can add things on the back of the rocket that aren't fins. And like we did with the nose cone, the conical shaped rocket, we could add cone shaped fins. And we can't call them fins because we're doing a finless rocket. But let's add nose cones to the side of the rocket. So under the design components, let's click on the body tube, and we're going to add a pod. So to put anything on the outside of the rocket, we have to use this button here called pod. And right now, I'm going to make this screen bigger. So the location of the pod, the front point of the pod, is right here, but we'll move that back later. You know, we're going to put it way back here. I don't know what we'll adjust this. We'll come back to this. Can this pod be ejected during simulations? Let's say no. And let's click OK. So a pod is like a placeholder. We're going to add parts to it. So like sustainer is a placeholder, and we added these parts to it. So now we're going to add parts to this pod. And the first thing we're going to add is a nose cone. And let's go with a 24 millimeter nose cone if we can find one. Okay, we use the PNC-C. So there's our nose cone. You can see it's hanging off the back of the rocket. Now look what happened. As soon as we added that nose cone, our center of pressure is now behind the center of gravity. So that nose cone did help. But I want to get rid of that shoulder right there. So to get rid of the shoulder, you come here to the shoulder tab, and we'll say clear those shoulder values, and it goes away. And then let's move this nose cone up a little bit. And we can't do it on this screen. We got to do it from the pod screen. So click OK there. So there's the nose cone. I'm going to go back to the pod, double click on it to edit, and from here we can move the location. So I can go, you know, I'm trying to line the back of the nose cone up to the back of the rocket, which is right there. So let's try 13.85. Ooh, that's really close. 8.9, too far. 8.8, close enough. Okay, so click OK. So now we have it's still finless if you don't think of that nose cone as a fin. Let's see what happens when we launch it, if we just have one on there. So I'm going to go back here and just going to do the flight profile. Not going to change anything. Flight profile, let's see. Oh, one of the things that I didn't change is I still have a rotation rate here. So now we will see it spinning because that nose cone will spin around as that rocket takes off. See it? Interesting, right? It's still spinning. Let's get it all the way to the end, and I want to see the trajectory. Click OK. And I want to zoom out a little bit. Pretty much the same kind of trajectory. It still looks like a number 7. And let's close that and let's see here. And it, with the extra drag of that nose cone, it didn't go quite as high. But let's do it again. This time let's turn off that initial starting roll rate. So I'm going to make that 0 and then do the flight profile again and see what happens. Okay, so we did get different results. Now it is going higher again. And look at this. It actually goes higher than the rocket that was spinning. And you might want to examine why that is. So we're doing all kinds of experiments here. Now we're learning about aerodynamics that we didn't even think we would be learning about. Let's go to the end here. And let's see the trajectory again. And zoom out. Okay, so now look at this one. This one, you know, before, when it was the number 7, this part here was kind of curved. Now it's a lot more straight, if we're looking straight down on it. So here's the launch point, here's the apogee point, and then here's where it landed. So we're getting different trajectories because we're changing the simulation. I like that. Okay, so even one nose cone off here says that this rocket is stable. Now I'm thinking I need to go out and actually build one of these rockets and actually test it. You wouldn't think it should be stable, but RockSim says that it might be. That's interesting, huh? Okay. Oh, okay, so the question that Terry had, does RockSim account for the propellant mass that's burning off? And the answer is you can see that here in the charts. So we're going to create a chart and we're going to just display the mass. So first I want to display, here's mass, and I also want to display thrust. Total thrust. And let's clear this out. Okay, so we're going to have a chart, and let's change the graph ending point to apogee, because it will reach apogee pretty quick, you know, and then plot that graph. All right, so looks like, can I make this larger? Okay, so mass right here is the orange line. So it starts out up here at a mass like almost 94 grams, and then the mass drops off as as something is happening. And what is happening? Well, we look at the thrust, and so from here to here, and you know, and this line right here shows when it burns out. And oops, I zoomed in too much. The mass goes down, and it continues to go down right up until this point here, which is burnout. Huh. There's like a little dog leg here that I wasn't expecting. Why would that be? So here's burnout. See, this burnout line should be right here where my thumb is on my screen, because that's where the thrust goes back down to 0. So my burnout line is like a little bit too early for some reason. But yeah, so that's, you know, so it does account for the propellant being burned off during the flight. There's a really good question. Terry says, try moving the motor forward in the tube. So he's thinking like, I think he's thinking like, let's make like a bottle rocket. You could theoretically do that in RockSim, but it would still be unstable because the stick doesn't contribute any forces to the flight in RockSim. In real life, the stick is going to produce drag. So what's a bottle rocket look like? So we'll design a bottle rocket. So let's save this design, start a new one. Okay, so this time we're gonna start with, call it a bottle rocket. And we'll go here, we'll create a body tube. So instead of starting with a nose cone, we'll start with a body tube. And this is where our rocket engine is going to go into. So it's an 18 millimeter, and we're going to make it short, so it's going to be, let's make it 2.5 inches. And click OK. Let's call it the engine mount tube. Click OK. And now we need to have this, let's put the, this is a motor mount tube. Let's load an engine. C6 3. So we loaded the engine in there. Click OK. If you look at it in 3D, what does it look like? It just looks like a tube with a rocket motor sticking out the back. And now we need to add the stick to make it a bottle rocket. So we'll do, again, anything on the outside of the rocket that's not a fin has to be put on with a pod. So we'll come over here to pod, and we'll just leave all that alone. And it put the pod right at the front of the tube. And we're going to add a tube to that. So now this tube, there's not a stick in RockSim, but we can create a stick by adjusting some parameters. So the outside diameter, let's make it a 1/16 of an inch, so that's 0.0625 inches. The inside diameter is 0, and that will make it a solid cylinder. And let's make the length 18 inches. Oops, not 28, 18. Okay, so we'll say OK to that. Okay, so now we have our bottle rocket. Looks just like a bottle rocket when I remembered when I was flying them as a kid. So let's save this, and we'll call it a bottle rocket. And hit save. Let's look at it in 2D. And it says it's unstable. Bottle rockets, they didn't go very straight to begin with, but let's see what happens when we launch this. So C6-3, same as before, flight profile, let's see what it looks like. It crashed. Let's see, how high did it go? Wow, it went 3,000 feet. I would have never expected this to be stable. Come on, I want to grab this corner, and it doesn't want to let me grab the corner. Okay, so there's the bottle rocket on the pad. Can you see that? I hope you can see that. So we launch it. Look at that. It goes, the flame was down here at the bottom of the stick instead of at the bottom of the motor. But we're at over 3,000 feet. And then at that point, it's kind of tail sliding. It's not feeling any forces trying to spin it around. That's interesting, right? I think it's going to land on the ground. It's going to stick the stick right in the middle of the ground. The center of gravity is way up here, even without, you know, with the casing of the motor is still heavy enough. It should flip over. But RockSim says that it's getting enough wind force from the side. Let me see the trajectory, see what that looks like. It did kind of wobble. Boy, it went a long way too. 1,157 feet. Wow, that was quite a launch. You know, it went, if you look at it from the top down, it's like a straight line. And it landed over there. That's interesting. I'm not sure that that's like 100% accurate, and in fact, I'm sure it's not. Bottle rockets shouldn't go that high. All right, cool. Okay, now we got people talking since we started talking fireworks. Mario Shuri, what is the limitation of RockSim 10 free? He's from Argentina. What is the limitation of RockSim? Oh, there's a lot of limitations, but as you can see, what we've done here today, we've done a lot of crazy things. So you got to interpret the results, like with the bottle rocket that we just did. Is it really going to go 3,000 feet on a C motor going that high? I kind of doubt it. So at that point, you got to say it's you've broken the limitations. You know, you've exceeded the possibilities. So you have to kind of look at it. Terry says it went hypersonic. It did go fast. Fatbank says, I created a RockSim file for a 2-fin rocket with the fins at 53 degrees. According to RockSim, the rocket is stable. How? I'm unsure. Yes or no? Yay or nay? And the answer, Terry, is yes. This one I've done as a real rocket. I've actually flown a 2-fin rocket, and I wrote a newsletter article about it. So let's see if I can find it, and I can show it to you. So go to How To and Guides, come here to the Peak of Flight newsletter, go to all the newsletters, and it's going to list all of our newsletters. And then, like before, do a Control F, and let's try 2-fin. 2-fin doesn't work. 2-fin. I know I wrote it. What would it be under? It's got to be, let's try fin. Fin we mentioned 78 times. So I got to click through here 78 times until I find it. Making airfoil fins, tie-dyeing fins, hassle fee, guillotine more than a fin jag, entering custom fins in RockSim, removable, replaceable, what is the best fin, expandable core, glossy finish, designing trapezoidal fins, repairing broken fins, styling your fins. Can you have through the wall on a minimum diameter rocket? Finless rocket using gas engine driven gas dynamic stabilization. Terry, if you're interested in that one, that does work as well. The newsletter 379. Let's see, can I open that in a new tab? Open link in a new tab, but I want to continue looking for my fixing warp fins. Flip out fins. Oh man. Using dowels instead of fins, and that's kind of what we did with the bottle rocket. Tube fins. There we go. Can you create a stable 2-fin rocket? Newsletter issue number 220. Let's open that one in a new tab. And so what he said, his was at 53 degrees. So here is, like looking at the back of a rocket. You can see the configurations. And, this one's at 90 degrees. And I've actually flown this. And it does work. I wonder if so here's some other designs with 2 fins. but I've flown this configuration right here, and this is stable. It kind of does like a little barrel roll on the way up, but it does work. And then here's some curved two-fin rockets, and here's a single-fin rocket. Yeah, so that's the two-fin rocket. This one is finless rockets using gas-driven or engine-driven gas dynamic stabilization. And so basically you have a rocket like this, kind of like what we designed, but you put holes down here. Let's see if I can make this bigger for you. How do I make this bigger? Where's the zoom in button? There it is. Let's move this way. So you put holes down here, and that does work. So here he put, well, actually he moved the motor further forward and extended it back. I've seen these fly. We have a guy in our club, Larry T. He flies these on occasion. They don't go very high because you're using a lot of energy that the motor, instead of pushing the rocket up, you're using that energy to keep it stable. So as the air is flowing over the rocket, it's being sucked in, kind of like a Venturi effect. With the engine putting thrust out, it's sucking air in. It's kind of like an airbrush. You know, you have air blowing out the nozzle, but it can suck liquid up through it. And they do work. You can't really model them, so that's a limitation. You can't model this in RockSim because getting the air to flow through the rocket, RockSim is the air is flowing around the rocket, not into the rocket. So it wouldn't know how to deal with it. So he made a Polaris rocket here. Yes, I have seen those fly. Let's see if we got any more questions. Oh boy, we've gone. Well, I started late because I screwed up at the beginning. Sorry about that. So yes, Fat Bank, these will fly. Let's save that. Let's open up. Let's see. Where's my desktop? Let's go back to a desktop. Finless rocket number 1. Let's open that up. Let's take the nose cone off. Rocket design components. Let's delete the whole pod, and the nose cone will go away. Say yes, yes. So let's add a fin. So we'll add a fin. It looks in the database, but we'll just ignore that, and it just draws a generic fin. You can see that down there. Let's change it to 2 fins. The thing is, if you look at this from the back, the 2 fins are opposite each other, but we can fix that. I'm going to change the material to balsa and click OK. So there's the 2 fin rocket like that, and if you look at it from the base view, it looks like that. It says it's unstable right now. So here's our center pressure, and here's our center of gravity, and it's unstable because the fins are on the opposite sides of each other. Let's launch it and just show you that, what it does. So choose an engine. C6, 5, come on, trying to grab 5. Click OK. And let's see, starting state, make sure we're not spinning, because that would be cheating. Okay, so at 582 feet, where before, well, before we were, if on a C-18, we were 1,000 feet. So this is not going quite as high. You can see, whoa, there it goes. It went unstable. It stayed stable a little ways, but now it's in the smoke. But it went unstable. Let's see the trajectory path. Let's zoom out. Okay, so there's the trajectory path. You can see the ground path. It's like a hook now. Yeah, I like that one. Let's close that. Now let's move the fins. So to move the fins, you go here to Design Components. You click on the fin set, and there's a button over here called Split. And we're going to split these fins into 2 fins. And we're going to say yes. So it says this operation cannot be undone. So I can't put them back as one set. Now they're going to be 2 individual fins. So I say yes. And so now they're still opposite each other, like that. But I can go and edit one of them, and I can change its radial position. And, oh, that's cant angle. I don't want to change the cant angle. Radial angle. So he said he had 52 degrees. Wow, those are really tight. So it's stable right up until even like 6 degrees. We're still stable. And then if we go a little bit further, then we're unstable. So at 10 degrees, we're unstable. But at 6 degrees, it says stable. That's in a perfect world. So let's set it at that angle. And let's launch it. See the flight profile. Okay, so there's the rocket sitting on. Oops, I lost the rocket. But let's launch it. See what it does. Rocket takes off, and it's 400, 500, 600. So it went higher. Still not as high as if we would have had 3 or 4 fins. Because it's doing some, it's yawing a little bit, yaw. Like turning sideways a little bit as it goes up. And you can see that like right here. Let's show the trajectory. I always lose the rocket when I do that. Okay, let's zoom out. So if you look closely at this rocket, so here's the trajectory, this black line. Let's change it to a different color so you can see it easier. Okay, so here's the trajectory line. So the path of the rocket is this way, but you can see that the body tube is not aligned with it. So it's kind of canted just a little bit, and that what it does is it's creating drag. If everything was aligned perfectly, this is why you want your rockets to fly straight along the path of the trajectory, because then they go higher and faster. So that's probably where we're losing our altitude, is because we're yawed just a little bit. There's pitch, roll, and yaw. This could be either yaw or pitch, depending on what you take as your axis. Okay. Mario Chiri from Argentina says he flies his rockets from Concordia Entre Rios. Ooh, I don't know where that is. Now you're making me interested, Mario. Okay, let's go on Google Earth and find out where Mario is launching from. Julia writes, little off subject, but if you want to put redundancy in dual deployment, how do you wire 2 altimeters to the charge? Or are there 2 separate charges for each of the altimeters? Julie, what I do is, let's see, I'll open up another browser here. Where else? Just give me a browser window. Let's go to ApogeeRockets.com, and one of our brand new rocket is the level 2, and this one is a dual deployment, and I did it with redundancy. That when I flew it, you don't have to, but I did. And so here is an image of my altimeter bay. All right, so I got one altimeter here, one altimeter here. Here's the battery for that altimeter. Here's the battery for this altimeter. There's a switch for this altimeter, and there's a switch for this altimeter, but it's on the opposite side of this board. It's just under the underside. And if you look, actually you can't see it from this photo, but I actually had 2 terminal blocks on each side. So there, I don't know, you can't see it, but it's just on the edge of this. This is an ejection charge well. That's where the ejection charge goes. So on the other side of that is one of these terminal blocks. And the terminal blocks allow you to run the wires from the altimeter to here, and then you run your igniter from the other end of the terminal block to here. So what I do is you have 2 terminal blocks, 2 igniters, but only 1 ejection charge well. Because no matter which of those ejection charge fires, it's going to burn all the black powder. Guaranteed. I have no doubt about that. So you don't need 2 separate ejection charge wells. You can have 1 canister holding all your black powder and just have 2 igniters going inside of it. And if one of them works and one of them doesn't, it's still going to work because it's still going to set everything off. The downside of that is if one altimeter doesn't work, you can't tell which one didn't work because it's going to burn everything. It's going to burn the heads off of both igniters too, because when one goes off, the black powder is going to go off, and it's going to ignite the head on the other E-match. So everything's going to burn. So that's how I would set that up, Julie. Okay, so but we wanted to go here to, what was the name of that? Concordia. Concordia Entre Rios. So we're going down here to South America. There's Concordia. Oh boy, that's a big city. There's a lot of people that live there. And they put the pin right near the plaza, right in the middle of the city. But where do you launch from in this area? I need a nice green field. And this is the Uruguay River. I'm sure you want to be far away from that. There looks to be some fields out here. This would be a nice field. So what you do is we need to put your launch site into the RockSim Pro. I mean, not the launch visualizer. So where's the launch visualizer? Where's the launch visualizer? Let's close that. I don't want to. I want to be here. The launch visualizer is rocksim.com. And I'll show you how to do it. And then you can send me your coordinates of your launch site. So what we've been in RockSim Pro, RockSim Pro has the launch visualizer built in. But if you don't have RockSim Pro, you can do everything that we did here today online in the launch visualizer. So you come here to rocksim.com, you log in. I have an account, so I'm going to just sign in under my account. And then you come here to the launch site tab, click on that, and you find your location. And Argentina. And let's see, it didn't find it. You'd think it would find Argentina. Come on, let's go 2D. I got to zoom out until I get to the world, and then Paraguay, Argentina. Oh man, I don't know what city that was. That was Concordia. Do we see Concordia, Argentina? Buenos Aires. I don't know where it is, but Cordoba. But anyway, what you do is you find your launch site. Let's say we wanted to launch right there. So what you do is you double click, and what it does is it finds the latitude and longitude, and then you say save this site, and when you save it, you're going to save it into your own personal database. So I would do Argentina, and it has the latitude and the longitude and the altitude above sea level. So you guys are pretty high up. You're just like us here in Colorado. And then you hit submit. You fill out all that information. So now it's saved in your own personal database. Now you have to share it with me. And so then you come over here to share this launch site, and you'll find the launch site, and it should be at the very bottom. See, here's Argentina, and you say make public and then share. And what it does is it will send me an email, and then I'll look at it, and then I can add it to the database of all the launch sites in the world. And if I zoom out, and if I come here to the United States, see all these pins? Those are all launch sites. So I would love to be able to add a launch site down here in Argentina. There's some other launch sites here. I think they're on the other side of the world. I thought I had some in Australia. It's kind of like these are being weird. All right, so let's see what we got going on here. Chris's Rocketry and More. Would you be able to make the body tube bigger towards the bottom half of the rocket for drag? That's a good question. Chris, why don't you give it a try and report to us and see what happens? I don't think it's going to have... See, RockSim assumes that body tubes don't contribute any forces to the rocket. That's in the Barrowman equations. So by making the tube bigger, it's still not contributing any forces. So in RockSim, it shouldn't make any difference, but RockSim assumes that you're not getting extra drag. You'd have to make the base pretty big, kind of like a cone, to make it stable. Terry says, Tim is sneaky. Yeah, I knew what you were up to, Terry. Johan is saying cell phone interference. Uh-oh. He says, Johan, he's in the Netherlands, he says, I scavenged a 90s Gruppner programmable transmitter with mixer function today. Now I can build a 2-rudder rocket glider. Cool. Oh, Mario was asking about the difference between the free version demo and the paid version. There is a couple of differences between free RockSim and paid RockSim. Free RockSim is 30 days that it will operate, and you are limited to rockets that fly to Apogee, so they don't come back down to the ground, so you can't see where the rocket's going to land. And we did that 20-something years ago, And the reason we did it was because we were getting a lot of people from Iran downloading RockSim, the trial version of RockSim. And we know that people in Iran don't fly model rockets. So why do they need RockSim? And so basically they're using it to try to target a specific point on the ground. So in the free demo, you stop at Apogee. And that's the limitation. But pretty much everything else is fine. There is no free demo of RockSim Pro, but like I said, you can use the launch visualizer to do everything the RockSim Pro can do. So you can see the rocket, see all those trajectories that we saw. There's a free trial on the launch visualizer. Again, it's 30 days. And again, it limits it to Apogee. Because again, we don't want people to use it to be targeting things that are on the ground. But once you pay, and the cost of the launch visualizer is $3 US, so it's not a lot of money. We're not making any money on the launch visualizer yet. It's going to be a long time. Roberto T. Oh boy, we have gone well over an hour, so I might have to hold this question. How can I add a canopy to my Zephyr model simulation? And can I add an eBay without add a double deployment to this model? And the answer is yes to both. So if you go back to our website, this is, I'll show you how, I won't be able to do it here, but we do have a RockSim Live that talks about how to add a canopy. So go to the home page and then just scroll down here to this image of the RockSim Live training, click on that, and that takes you to our archive. And then on our archive, do a Control F on your keyboard. On a Mac, it's Command F. And then type in, you get this little search bar at the top, and then type in canopy. And episode number 6 shows how to add a cockpit canopy to a nose cone. And it's at 36 minutes into the video. So you just click on the video, go to the YouTube, scrub through the timeline to 36 minutes, 24 seconds, and that's where we start that topic. And then how to add a eBay to a rocket. And I think we talk about that too. So eBay. We talked about it 4 times. Moving an eBay off center line. Okay, so episode number 8, how to add a dual deployment eBay to an existing design like the Zephyr. Just like you were talking about. So go to episode number 8, and it's at 24 minutes into the episode is where we talk about adding that eBay. If we would have had more time, I would have answered that question. Carlos K says, I recently ordered some dainty parts and kits from Apogee. Perfect, speedy shipping. Thank you, Apogee. Well, thank you, Carlos, for the order. We do appreciate. Terry Wheelock says, yes, the cone on the bottom works great. I will do a video today on that rocket on my channel. Oh, Terry, that's cool. I would love to watch your video, Terry. Last week we talked about short, fat rockets and drag. And we talked about adding a cone, and he says that it works great, which is good to hear. All right, so we have gone way long, even though we started late. And I apologize again for clicking on the wrong button and ending the stream like about 6 seconds into it. So I apologize, but thank you for watching and sticking with us. You guys make this Wow, we had a lot of viewers today. 61 views. Currently 15 of you are here right now. If you're watching this on replay, you are always welcome to come and ask your questions live here. We're at 2 p.m. Mountain Time Zone on Friday afternoons. That's when we do it. We try to do a block out an hour, but we typically go a little bit longer. And we will be back again next week, which now we're going to be into April because tomorrow starts April 1. So we're going to be April 6 or 7 next week. But we will be here. I'm not planning on going anywhere. So thank you for coming. I got to end this because you've been